Today we are going to discuss some important applications of stack data structure, like stack data structure applications like recursion, and we have infix to postfix expressions. We can convert prefix to postfix, and we can evaluate the postfix expressions, and then we can do the problem of tower of an eye. These kind of problems we can use stack. Hello everyone, this is Sharda from GoEduHub Technologies, and I would like to welcome you again for the session number 9 in DSA with Python training. Can you please confirm me, am I audible? Please write in the chat window so that we can start. Okay. So guys, today we are going to see what is the basically expression. First of all, I'll tell you what is the expression, and then we will see, let me write here. First we will see expression, and then we will see different type of expressions like infix, postfix, then prefix, all these different type of expressions. Like here I'm writing 4 plus 5. What is this? This is an expression. Expression can contain variables, constants and operators, right? This expression can be a plus 5. Here a is a variable. A can be another expression like a minus 1. It can be like 5 into 6, something like this. So these are the basically expression. Okay. And what we are going to do, we are going to do the implementation of these expression. Like here I'll write 5 plus 6 into 7. Now this is the expression. How can I solve this expression? There would be the two solutions. Like one is, first I will do addition, then 11 into 7, then 77, and second solution is 42, 6 into 7 plus 5. So 47. Which one is the correct answer? There would be only the one answer, but here I am getting two answers. So which one computer will evaluate? How it will evaluate the things? Okay. So for this, what we will do, we will see two things. One is the precedence, and second is associativity. Basically, first we will understand all these expressions, and then we will do the implementation using the stack in the Python program. Okay. So what are the precedents? Like different expressions have different precedents. Like we have precedents for the equal precedents for the plus and minus, equal precedents for the divide and multiply. Okay, here I'll write some rules for the precedence. Like highest precedence I have for braces. Highest, number 1 I can say, and number 2 I have for power. Okay, and number 3 I can say for multiply and divide, and number 4 I can say for plus and minus. These are the things we need to keep in mind for the precedence. And most of you already know, because these things we are learning from the RC programming. So basically, braces have highest precedence, then power have second level of precedence, and then multiply and divide third precedence, and then plus and minus having the fourth precedence. Okay. Now if I talk about the associativity, what is the associativity? Basically we can solve a expression left to right or either right to left. That is the associativity. Like sometimes what happen in an expression, we have in this expression we can solve this expression like multiply having the more precedence than the plus. So we can solve this first the multiply and then plus. So optimal solution would be 47. But if I'll have some expression like this, 5 plus 6 into 7 and then plus 30 divided by 5. If I have expression like this, then here plus and here multiply and divide both have equal precedence. Then which one I have to first solve? Okay. So here second rule, I'll check out the associativity. So in this associativity, I'll take left to right. So here I'll write the associativity like 4 except the power, all of them we have left to right. And for the power we have right to left. Okay, so multiply, divide, plus, minus, all of them we have left to right. Here the braces also we have left to right. Basically we will solve the expression left to right, and in case of power we will solve the expression in right to left. Like here I'll take another example, 2 power 2 power 3. Here there is 2 symbol of power, then how I can solve? Which one I have to solve first? So here I'll solve from right to left. So first 2 to power 3 and then 2 to power whatever the solution I'm getting. Not here. Here I'll not solve from left to right. I'll solve from right to left. So this is the associativity for the power. And if I talk about this expression, I'll solve this expression from left to right. So 5 plus 42 plus 6. Okay, then also plus have same precedence. Then we will again see the associativity. These are the certain rules. Okay, so how to solve a expression? That is simple expression. If you have a expression in the mathematics, then how you will solve and how the computer will solve. Okay, like 5 plus 6 into 3 plus 30 divided by 5. This is the simple expression I am having. Okay, and sometimes we also have 6 plus 2. Here a braces. This is a expression. Now I need to solve this expression. First of all, you need to take, like here we have braces. So braces having highest precedence. In the first scan, I'll solve this one. All things are remaining same. So here plus 8 and remaining are the same. In the second scan, what happens? I'll check the other operators. Like here one operator is this divide and one is multiply. What is the operator? Operand, you know, I think. Operator is basically symbols. A expression is like operand and then operator. Like I'll write expression, operand and then operator. If I talk about a binary expression and then operand. This is a simple form of an expression. Okay. So first I'll solve the braces and then multiply and divide have equal precedence. So which one I have to solve first? So I'll go from left to right. So here 5 plus 6 into 3 is 9. Okay. In this scan, I'll solve this one only. And then in the next scan, 5 plus 9 plus this 30 divided by 5. 6 plus 8. Now all 3 plus have equal precedence. So first I'll solve the left one is 14 plus 6 plus 8. And then 20 plus 8 and then final output is 28. Okay. So basically this is the simple way how we will solve a expression, and a human being how to solve a expression. We have certain rules, but if I talk about the computers, in the system we need to take care about all these things, like about the operand, operator, and then precedence, and then associativity. All these things we need to keep in mind. So it is the difficult task for the system, for the operators, for the compilers, to keep in mind all these rules. So what we will do, like infix expression, these are the infix expressions. I'm talking only about the infix expression. Okay, this is the infix expression. And what is the first, we will understand postfix and prefix. Then we will talk about why we using the postfix and prefix in place of infix. Okay, so infix you know, and like 5 plus 6 into 7. This is an expression. This is an infix expression. Now I'll write its postfix expression. What is the postfix? In the postfix, the expression in the form of like first operands, operand 1, then operand 2, and then operator. Means we can say operator is followed for every pair of operands. You can understand here, like this is, we will convert in the postfix. So 5 plus 6, 7 into, and then again this is the one value and this is the another value, and operator is plus. So we will convert 5, 6, 7, multiply and then plus. So this is the equivalent postfix. Okay, we have an expression like this, and first we need to evaluate anything. Then what we will do, operand first and then operand second, and after that we will write the operator. So first we will solve 6 into 7. So we write like this, 6, 7, and then this operator. Then this is the again new expression, 5 plus 6, 7, multiply. So in this expression, first operand is 5, second operand is this 6, 7, multiply. So 5, then 6, 7, multiply, and then we will write this plus after this. So this is the postfix equivalent. Okay. And then if I talk about the prefix equivalent, in the prefix we will write first operator and then operands. Okay. So prefix equivalent is like 5 plus multiply 6, 7. This is 1 and this is 1, and then plus 5 multiply 6, 7. This is the prefix equivalent. Okay, so I think now you should clear with what is the expression, what is the infix expression, what is the postfix expression, and what is the prefix expression. Okay, yeah guys, some people have corrected me. 6 into 3 is 18. Yeah, actually I have done the sum. I think 6 into 3 is, in place of 9 here should be 18. Don't go to the by calculation. It may be written the wrong way, but actually I just want to say you what is the basically rule, how we will follow the rule. Okay, so postfix equivalent we know, prefix we know, infix we know, and expression we know. Now what we will do, we just want to convert infix to postfix with the help of a stack. Okay, and we know the basic concept of a stack, how a stack works. Stack have only one end, and using that end we only do the push and pop with the operations. Okay, so with the help of stack, if you solve infix to postfix, suppose we are just taking first example, infix to postfix conversion. Okay, So what we will do here, we take an expression and then we put that expression into the stack and then we will convert into the postfix. So like we have an expression a plus b divided by c, something like this. And now we need to solve this with the help of the stack. So there would be the certain rules we have to follow for doing this operation, like infix to postfix conversion. Let me open the website. I'll show you certain rules. Or you can see in the description of this video, there is a link, infix to postfix. Okay. Here we need to follow the certain rules. Like what are the rules? Here in the second answer you can see the rules. Infix to postfix conversion. What we will do? Print operands as they arrive. What is the operands here? A plus b divided by c. If I talk about this a plus b, here operands are a and operands is b and c. You can say we can make a list of operands. Operands is a, b and c, and operators is plus and divide. So whenever you are getting the operands, you print as it is. You don't need to do anything. First rule is operands, print them as it is. If a stack is empty, initially stack is empty. Stack empty. If your stack is empty, one thing is, then we need to put incoming operator into the stack. Push incoming operator. Inside the stack we are going to put only the operators. Operands we never put. Operators. What is the operator here? Plus and divide. So initially my stack is empty. Okay. And a I'll print as it is. In this expression a I'll print as it is. Because if any operands come, I'll put that as it is. And then second option is plus. So stack is empty, I'll push the plus here. Okay. Now b is a operand, I'll print as it is. Now divide is a operator. Now I need to take care two things. If my incoming symbol has higher precedence or my incoming symbol has lower precedence than the top of the stack. Top of the stack, what is the top of the stack here? Plus. Now I need to compare the precedence of this divide with plus. We compare precedence of both symbols. So there is a two rules. First rule is if precedence is higher for the incoming, precedence of incoming operator is higher, then what we will do? Push it on the top of the stack. If precedence is higher for the incoming operator, if incoming symbol that has higher precedence than the top of the stack, then we will push on the top. So here you can see precedence of divide is greater than plus. Then what we will do? We will push here. So the second symbol inside the stack, we will push divide. Okay. And after this, C is as it is. So if I'll write its postfix, then A, B, C, and after traversing all the elements, what we need to do? We will pop out all the elements from the stack. So A, B, C, and then divide and then plus. This is the equivalent postfix. And you can see this is the equivalent postfix if you manually do this. Okay. So one rule we have written, if incoming having higher precedence, then we will push. And second rule is if incoming having low precedence. Okay. If incoming having lower precedent, then what we need to do? We need to check, we need to pop out whatever the inside, we need to pop out and then print the top. And then we will test the incoming operator against the new top of the stack. Like in continuation of this example, I am writing one more expression here. A plus B divided by C and here minus D, suppose. Okay. So for this, what we have inside till the C, we have inside the stack plus and divide. Now my new operator will come minus. Okay. Minus operator, we will check the precedence of minus with divide. Okay. And minus operator precedence is less than the divide. Okay. Then what we will do, we will pop out this divide. So A, B, C we already have, and we pop out this divide. Okay. And now we will again check, we cross out this, we check plus or minus precedence of new top with this operator minus. If incoming operator has equal precedence with the top, then what we will do? We will check the associativity rule. Guys, are you getting the things? Can you please give me a quick confirmation? Okay. Meanwhile, I am continuing this session. So, what we are doing here, 1/3 rule we need to write. If incoming having equal precedence, then we need to check out associativity rule. And associativity rule, what associativity rule says, if associativity is left to right, then we pop and print the top of the stack and push the incoming operator. Okay. And if associativity is right to left, then push the incoming operator. So here the rules are written. Like first is we have seen print the operand as they arrive. We will see one more example, don't worry. But the rules what we need to know. Print operands as they arrive if stack is empty or contains a left parenthesis on the top. Then push the incoming operator into the stack. I told you only about the if stack is empty, then we will push the incoming operator. And same thing happens if stack having left parenthesis on the top, then also we will push. If we talk about the parenthesis then. Okay. And if incoming, now skip third and fourth, I'll tell you. Incoming symbol has higher precedence than top of the stack, then what we will do? Push it on the stack. If incoming having higher precedence, then we will push it. If incoming having lower precedence, then what we will do? We top of the stack, then we pop it. Okay, and print the top and then test the incoming operator against new top of the stack. Here we need to remove this line is wrong. Push it on the stack. This is wrong. Okay. What we will do, if incoming symbol have lower precedence, we will correct it. If incoming symbol have lower precedence, then we will pop out the item from the stack and then test the incoming operator against the new top of the stack. Okay. And if incoming operator has equal precedence with the top of the stack, then we will use associativity rule. Equal precedence, in the case of equal precedence, we will use associativity rule. And what are the associativity rule says? Left to right. If associativity rule is left to right, then pop it and print the top of the stack and then push the incoming operator. So in our case, here we are comparing plus and minus, both having equal precedence. So we will check the associativity, and in the associativity for the plus minus we have associativity left to right. Okay, left to right. So if we are doing left to right, then what we need to do, we need to pop out the plus. So here we pop out the plus and we put minus inside the stack. Okay, so inside the stack is minus now, and this is A, B, divide and plus is outside. And when you complete, you will do the traverse of complete expression, then you will pop out all the elements of the stack. So here expression is A, B, C, divide plus minus. And manually you can try, this would be the same. Okay. And if expression is like this, let me take another example. A plus B plus C divided by D into E and plus D. Okay. And power of F, something like this. Then what we will do first we will check for the first A. For operands, we will put as it is operand. Okay. And here plus comes, stack is empty, we will put the plus inside the stack. Now again B comes, we will keep the B as it is. Then plus comes. Now we will check the precedence of top of the stack with this plus. So plus and plus having equal precedence. They having the equal precedence, in this case we need to check out the associativity. Okay, and associativity is left to right. Then what we need to do, we first pop out this. So pop out this, we put here. Okay, and now my stack is empty. Now we push this second plus. So here plus is inside. Okay. And then C divided by D. So C we will put as it is. And you can say divide having higher precedence than plus. Then in case of higher precedence, we will put into the stack. Okay. So we put the stack. And then this multiply. Multiply having equal precedence with the divide. In this case, what we need to do, we need to check out the associativity left to right. So here we pop out this divide. Okay. So we put the divide here, and now my stack becomes plus, and we need to push this multiply. So plus and multiply. Now plus comes. Okay. Plus having the lower precedence than the top of the stack. Then what we need to do? We need to pop out this. Okay, we will pop out it, so we print here. And now we compare with the next top of the stack. Next top of the stack is plus, that is the equal precedence. In the case of equal precedence, we need to pop out this and we need to put this. So plus would be here and this plus is inside. Now my stack having only plus. Okay, and now come to the power, and power having higher precedence than the plus, so we will put inside this. And now we have we are having after the plus, before the power I need to write the D. Okay, and now F we need to write here as it is. Okay, and now my expression is completed. Now I'll pop out all the items. So power is here and plus is here. This would be the equivalent postfix. You can solve it manually also. Like here, power having the higher precedence. So first of all, we will solve this. So df this, and here in case of multiply and divide, it's equal precedence. So we will solve first from left to right. So C D this, okay, and multiply E. So E multiply. Okay, this one we have solved. Now we have here 1 plus and here 1 plus and A plus B. Okay, so first we will solve this one, then we will solve this plus, and at the end we will solve this plus. So AB plus and then CD E multiply plus and then final output would be the same. Yes, I forgot to write the E. Okay, here there would be somewhere E. I don't remember, maybe here. Okay. No, it should be before the divide, no? Here. Okay. So basically what I'm trying to tell you how to convert infix to postfix, and this is very important topic, guys. Like if you are going to write in any exam like GATE, always they will ask some question related to infix, postfix and prefix. Okay, now we will write the program. How we can write the program for this activity? I think you got the concept. Okay, until now if you have any question you can ask me. I'm giving you the time if you have any question regarding infix to postfix conversion. Okay, otherwise I'm just going to write the program, and let me come to the post. You can see here. Okay, these are the certain steps. Yeah, I have left out the braces. If incoming symbol is opening braces, then we will push into the stack. This is the one rule. And if incoming symbol is closing braces, then we will pop the stack and print the operators until the left parenthesis is found. This is the one more rule we need to take care. So these 8 steps we need to take care, and associativity rule we should know. Then we can solve any infix to postfix conversion and we can write the program easily. This is the basic concept. You should know this concept. Okay. So let me write the program. I'll explain the program, how you can write the program. Okay. I can explain the logic first and then we will come to the code part so that you will get the more clear idea. Okay. Here I need to take care certain conditions. Okay. Certain conditions I need to take care. First is simple for the stack. I'll need to write a class, and inside the class I need to write certain functions like push, pop, is empty and seek. These functions I'll write. Okay. After this I need to write two more functions. One is it's taking is operand. Okay. First is checking if it is an operand or not. Okay, and one more function I'll write here to check the condition. Def infix to postfix. This is for conversion, and here we need to pass the expression. Whatever the expression we want to evaluate. So operand, how we can check the operand? We can give the certain conditions like operand can be a number or operand can be alphabets. So here I can write a simple condition. If my operand is, like, I'm taking a variable I, here I need to pass this I. If I in is alpha or is number, these two conditions I'll check it out. Then it will return me true. Okay, so what I will do, if it is an operand, then don't do anything, I'll just print it. And otherwise I'll do the operations over the operator. So in case of operand, I don't need to do anything. I'll print. print as it is. Otherwise, if it is an operator, then I'll go to this function. Okay, and inside this function, what I need to do, I need to traverse the complete expression. So for this, I need to write a loop. So for I in whatever the expression we have. Okay, and inside this expression, first condition, I need to check out if it is a binary expression or not. Okay, so what I will check, if length of this expression, this is proper expression or not, is divisible by 2. Okay, then I can say it is a correct expression. Sorry, divisible by 2, then I can say it's incorrect. Because what I need, at least I need odd numbers. Like if I have an expression 4 plus 5, then at least 5 things we have. Is 3 things we have. If expression having one more plus 6, then we have 5. So we have total length either 3, 5, something 9, like this, odd numbers. Then we can say our expression is correct. Otherwise we can return incorrect, is return false, or you can say, you can print here incorrect expression. Okay, so this is the if condition I need to write, and then I need to write certain more conditions. Else if. Okay, here what I need to write, I need to check out either it is a plus, minus, divide, power, or braces. So 2 conditions I'll write for the braces, like elif, here elif, multiple elif I need to write. So first I'll check if my I in, like plus, minus, I'll take a list of these, plus, minus, multiply, and divide, and power, something like this. Okay, then here I need to check out the condition, stack is empty or not, and precedence of this current element is less than equals to precedence of the top of the stack. So here I need to check out the conditions, top of the stack, precedence, and empty stack. Okay, if stack is not empty and top of the stack is greater than the current element, top of the stack having greater than this, then we will pop out, otherwise we will push. Like incoming character having less, incoming operator having less precedence, then what we will do, we will pop out. Incoming having less precedence, then we pop. Okay, and we pop, and we will pop until, like, we will check for the next, and if next is also having the less precedence, then also we pop, otherwise we push. Okay, so like this condition we will make here, we need to write here a while loop. Okay, and 2 more conditions I need to write for the braces. Like if it is a opening braces, I is this braces, then I need to push. And if it is a closing braces, then what I need to do, I need to pop out. And till what I pop out, I found opening braces. Okay, so these conditions I need to write in my program. Clear guys, concept clear, what we will write in the program? No, Nimal is asking a question, ma'am. What if infix expression contains a special character? Is operand function work? We need to take care of these conditions. Like in a program, we need to tell like what are the operators can be and what are the operands can be. We can limit our program. Like here, I'm taking only the alphabets and numbers, so it won't work for the special characters. But if you want to take care, like you just want to treat special character as a operand, then you need to include in this condition. Okay? So now we will write a program. Got it, guys? Concept you got it? Now I'll write the program in the Python. How we can solve this question. Okay? And you guys also can write the program along with me. Yes, Muthu is asking a question. Until we get the closing braces, we have to pop out. Yes. Okay. Now here I'll write the program. Okay. This is little bit lengthy program, but I'll write it thoroughly. Don't worry about it, so that you will see the output. Okay. So what I will do first, I'll write the simple program for the stack. So here I'm defining a class infix to postfix. Okay. I'm giving this name to the class. Okay. And here I'm taking a dictionary of precedence. Okay. Precedence, inside the precedence, I need to tell out about the precedence, like for the braces I have with precedence, for the divide, multiply, plus, minus, we need to specify. Okay. So who have the highest precedence? Braces having the highest precedence. So we need to tell it like we will define like a dictionary. Okay. So first key I'm defining closing braces. Okay. And this closing braces I'm giving precedence 1. Okay. Similarly for the opening braces I'm giving precedence 2. Okay. And like minimum value is minimum precedence. Okay, let me write it. And then for the plus, I'm giving 3 precedence, and for the minus, I'm giving 4 precedence. Sorry, 3 equal. And for multiply, I'm giving 4 precedence. And for divide, I'm giving 4 precedence. Okay. And here I'll remove the braces. I'll keep only this one. Just wait. Let me write the small one. Then I'll change. And 4, 3, 4, 5, 4, and then which one? Power. Power I'm giving 5 precedence. Okay. I'm taking simple dictionary. You can take symbols which one you want. I'm just writing simple plus, minus, divide, multiply, and power. And here I don't need to take, I need a control. Okay, this is the simple dictionary I am having. And then here I'll define a stack underscore underscore init, and here I need to pass self. Okay, and here I'm defining self dot items equals to empty. Stack is empty, and then I'm taking one more variable. You can keep it and otherwise you can leave it. It is simple size calculating. Okay, equals to -1. We don't need it, we can. Okay, and then push self comma value. Okay, you know the program of stack. In the last class I have told you items dot append value. Okay, and def pop self I need to check out empty if self dot is empty. Okay, then I can return 0 or false, and else I'll pop out return self dot items dot pop. Okay, def is empty. I need to define is empty self return self dot items length of items now. Length equals to 0. Okay, and top of the stack also I'll define here def seek self. Okay, if self dot is empty, then I'll return false or 0. Return false indentation. Okay, else I'll return top of the stack, else return self dot items, and then inside the bracket -1. Okay, now I'll define the new functions. This is the simple stack initialization. Now I'll define two new functions. One is checking for the operand and another one is infix and postfix. Okay guys, def is operand. Okay, is operand, I'm checking self comma I need to pass here the value I. If I in, here I need to check out the two things, either it is a alpha like alphabets or it's a number. So you can take anything. So here we have a function is alpha. So I'm checking I dot is alpha. Okay, this is a function, Python function is alpha Okay, and 1 for function for the number I don't remember, but I'm checking for the only the is alpha. Let me check it out. I don't remember is alpha is syntax is correct or wrong, because it's not changing the color. Is alpha in Python syntax I need to check out. Is alpha is built-in function used for string handling. Methods return true if strings are alphabets. Okay, so is alpha is correct. Okay, if it is a alphabet, or similarly we have for one function for the numbers, I don't remember the name of that function, is num or something like that. Okay, and then what we will do, we will return true, and else we will return false. Okay, now we will define one more function, def infix to postfix. Infix to postfix. One more function I'm defining here, self, and what I need to pass here, expression. Okay, and here I'm taking certain variables. Okay, initially I'm taking a postfix string, that is the empty string. Okay, and now I'll print here, print postfix expression after every iteration. Postfix expression after every iteration. Okay, and here I'll write a loop for I in expr. Okay, and here first I'll check either my expression is valid or not. Okay, so for this I need to write a condition if length of expr divide by 2 equals to 0. Then I can say it's an invalid syntax. Print invalid infix expression. Okay, and I'll return false. Okay, else here I need to write some more conditions. Okay, elif self dot is operand. I need to check it out either it is a operand or not. Okay, so I'll call is operand function is operand, this one. Okay, and inside this what I need to pass, I need to pass I. Okay, it will return you either true or false. If it is a operand, then what I will do, I'll print as it is, I'll add to the postfix. So postfix equals postfix plus equals I. Okay, elif, this is one condition, I'll print as it is. Otherwise what it can be a operand. Okay, I in here I am taking a list of operands, certain operands. You can change as per your requirement. Minus, plus, minus, and here I am taking divide, and then multiply, divide, and then power. I am taking only the 5. Okay, and if it is an operator, then here I need to write a loop while. Okay, first what I'll check, if it is like this loop will run if it is not empty. So length of self dot items. Okay, guys, are you following along with me? Yes, I have given the same value to multiply and divide because both having the equal precedence. Okay, Okay, Hemant have corrected me. In false, F should be capital. Somewhere I have written the false. Yeah, this one. Okay. Next, they have same precedence. Okay. And Hemant in seek, star in seek. Where is the seek? What is the star? In seek star. I'm not getting what you want to say me. I think seek is correct. Seek is basically is empty, it will return the false. Else self dot items -1. Okay, check it out. Next is I'm defining infix to postfix. So basically infix to postfix, what I need to write here, I was writing if my items list is not empty. Okay, means my expression is my stack is not empty. Here items means stack. I'm checking the stack. Okay, and I need to write one more condition, and I'll check the precedence. So self dot precedence. Okay, and precedence of I, if precedence of I is less than equals self dot precedence okay, and precedence for what? Top of the stack. How I will get the top of the stack? By calling the seek function. So here I'll call the seek function self seek. Okay, so this top of the stack is greater than equals. In both the cases, if I have precedence is greater than or is higher, then what I need to do? I need to, if precedence of incoming symbol is higher, then we need to push. Otherwise, if precedence of incoming is less than the precedence of top of the stack, means top of the stack precedence is greater. So what we need to do? We need to pop out. If top of the stack having more precedence, we need to pop out. And if top of the stack having equal precedence, then also we need to check out two things, associativity rule. Okay, so I was writing here top of the stack is precedence of top of the stack is greater or list is stack is not empty. In this case, okay, what I will write here, I'll write postfix plus equals self dot pop, because I'm popping, and whatever I'm popping I need to add to my result postfix. So self dot pop. Okay, and if this condition is false, then what I need to do? I need to push self dot push I. I'll call push function. This is the condition. And one more thing, if we have braces, elif, one more condition, I in opening braces, then we need to provide here push self dot push. Like if we have this incoming braces, rule number this. Third, if incoming symbol is opening braces, then push it into the stack, and closing, then pop out. Okay, so for the opening we need to push out, and we need to write one more condition, elif I in closing braces. Okay, then we need to pop out. So here I'll taking another variable O equals to, because here also I need to pop out until incoming, until the next operator in the stack, top of the stack becomes opening braces. Till this stage we need to pop out. So here I'm taking another variable self dot pop. Okay, and we need to check out one more condition while O not equals to, okay, while O not equals to opening braces. Okay, then what we need to do, postfix plus equals O and O equals to self dot pop until we need to pop out. Okay, this is the intermediate stage, and we will print the postfix. Print postfix. Okay, and this is the end of the loop, end of for loop. Okay, okay, now we will create the object of this class and then we will call. Let me come outside. We will create an object as infix underscore to postfix. This is my class name, I think. Same name I have written. And then I need to input a expression. Expression equals to input. I need to enter a expression. Okay, and then I need to check it out. Result equals to s dot infix to postfix function. I need to call infix to postfix, and inside this I need to pass the expr. And result, if result is not empty, if result is not equals to false, then we will print it. Print the postfix expression. What is the postfix expression as? Result. Okay, so I hope you are getting the things. I'll run this. Maybe it will run. There may be some errors because I have written the program, so there may be some syntax error, some typo mistakes. It's running. Let me check it out. Yeah, invalid syntax. Yes. Def underscore init in. This is correct or not? Okay, here. Okay, now I'll run it. Here I need to give an expression. A plus B into C. Okay. Yeah, one thing, what I have done here, this is printing only the operands. But I need to pop out all the operators which are inside the stack. What is the inside the stack? Plus or multiply. So I need to pop out them. That also I need to include inside the expression. That's why it's only giving the letters. So here also I need to write one more loop. Okay, I forgot that loop. What loop I need to write? Like what I have done, I have put it inside the stack and I have printed operands. So for printing the operators, I need to write one more loop. Okay, and that loop is, we will run over the length of the stack, and here our stack is items. Okay, so when we ending this for loop, we need to write one more loop here. Okay, while, and here we will write this loop for the length of self.items. Okay, and if self.seek top of the stack equals opening braces. Okay, then what we will do here, I need to write condition for the opening braces, self.pop, okay, else I need to pop out and need to add to the postfix. So postfix plus equals self.pop. Okay, and at the end I'll return postfix. Okay, I think now it would work. And this return would be equals to the while. Let me run this. A plus B into C. Something under expression, this, there is some error. Let me check it out. It's returning only the A. Why it's returning only the A? This while. Okay. This while should be outside. At the level of 4. I think now it won't track. Let me run it. A plus B into C. Yes, now it's perfect. A plus B into C, A, B, C star plus. This is the postfix conversion of this infix. Actually, I have written the while inside the for loop. That's why it was not working. While should be outside the for loop. It should be at the equal indentation to the for loop. Like one loop is this one. Okay. And this should be outside this for loop. Okay, guys. I think this is enough for converting infix to postfix. Now the second thing you can do, like we can convert from prefix to postfix also. Got it, guys? We have completed one program, converting infix to postfix. Simply we can also do like evaluation of postfix expressions. This is the simple thing we have converted. Okay, and one more thing what we can do, we can solve the postfix expressions. We can evaluate the postfix expression. And why we are doing this? Yeah, one thing I need to tell you, like we are working over the human beings are good for solving the infix, but for the machine to need take care different things for the infix. So that's why we are using postfix or prefix in place of infix, because postfix and prefix evaluation is easy. Compiler, what compiler will do? Compiler scans the expression either from the left to right or from the right to left. So compiler first scan the expression to evaluate the expression like A into B. Like I can write here. Okay. If we have written A into B. Okay. Okay. What it need to do? It need to scan 2 times to evaluate this expression. Like first operand it will get in first scan, and then it will get the operator and then operand. So first it will get A, then B, and then operator. Okay, and if we have expression something like this, A, B multiply, then in the one scan it will solve this. We for the system don't need to do the repeated scans. And obviously infix solution will take more memory and more time. So for the machine to solve postfix expression is more easier. Because postfix expression, what happens? Machine solve with the help of a stack, and it will easily put the A and B, and inside the stack it will put directly symbol and it will solve easily. Otherwise it need to take care the 2 scans. Okay. Now we will see how to evaluate the expression. Like infix we know, postfix we know. Okay, so it will save the repetition of the scans, postfix. And now how to solve this postfix? Like we have converted this postfix. Either we have certain values, like in place of ABC we have some 10, 20, 30 multiply plus. We need to want the result. We want what would be the solution of this expression. So how this can be done? This also we can do with the help of the stack. Postfix evaluation. Balance bracket problem I have given you in the last class. I hope you have solved that question. Have you done that? Evaluation. How we can do the evaluation of postfix? Sorry. You need to make the program for this. Evaluation of postfix expression. I'll tell you the idea. Just give me 1 second. Okay. Here what we will do, like basic algorithm you can say. What we will do, we will take a stack. We will create a stack to store the operands. Create stack to store operands. Like A plus B multiplies C. So it's a postfix. A, B, C multiply and then plus. So it will store the operands. What are the operands here? We have multiply and plus. So it will store the operands like this. Okay. Then it will pick first operands and first operator and perform the operation. Order should be some other, but I am telling you it would happen like this. It will pick first operand, first two operands, and then it will pick the first operator. Okay. So what we will do, we will create a stack to store the operands and scan the given expression, and we will do the two things. If element is a number, we will push it to the stack. Is number. Okay, we push the stack. And if element is operator, then what we will do? Pop the operands from the operator, from the stack. Pop operands from stack. Okay. Like we will take a numbers like 2 plus 3 into 4. Okay. If element, we are scanning from left to right. This is just for understanding. Don't take it for granted. This is not the perfect thing. Like 2 plus 3 into 4. Okay. If element is number, we are scanning from left to right. It is a number. Okay. Then what we will do? We will push to the stack. If element is an operator, like this is an operator. This is an operator. But we are talking about the postfix evaluation, then this would be 2, 3 multiply 4 plus. So what happens? 2 will go, 2 is a number, 3 will go. And then element is a number, we push the stack, these two we have traverse, and now element is a operator. This multiply. Then what we will do? We will pop the operands for the operator and we will evaluate. Like 2 and 3 we will pop out. And 2 into 3. Similarly, this process we will keep continue until we will get the solution. Muthu is asking a question, ma'am, please explain the last while loop again. Actually, last while loop is nothing. It's a simple. I have written 4. This is like I have put it all the elements inside the stack. Okay. And now I just want to pop out. So here what this condition I am writing for the braces, and this is otherwise, like if I have inside the stack, I have all the plus minus operators. So I'll pop out every. This is for only for the stack. Inside the stack, whatever I have put it, I need to pop out. That's all. Okay. So if it is a braces, opening braces, we need to pop out until we will get the closing braces. That I told you. Here we have take care this condition also. If this is closing braces, then we need to pop out until the opening braces. And so one condition is for opening braces. If it is a opening braces, we will pop out, and other condition also we directly pop out. Okay. So same thing you will do, you will write a program for postfix evaluation. Same concept, almost same concept. So write a Python program for postfix evaluation. That is your assignment for tomorrow. Okay. I think this is enough. We have seen application of stack. So almost lots of questions we have seen in the stack. Now we know how to implement the stack. Okay, and we know different applications of the stack and different problem statements we have done in the stack. Okay guys, I think this is enough for today. If you have any question till now, you can ask me. And in the description of this video, this notes link is given. So here the same program that I have written, and here is the rules for the infix to postfix, and even we have written one example, like this is a example expression: a plus b into c, d divided by e, f into g. All these, this is a expression, and how we can solve this expression step by step. Here output is written. Like first we will see the internal braces. Like then when we have multiple braces, then which one we need to first solve until we got the closing braces. So whenever we get the closing braces, we will solve this one first. Okay, and then the next bracket, next closing bracket, we will solve this. And inside this, if operators have equal precedence greater than, then if it is having equal, we will see the associativity rule. Okay, all these things. Okay guys, thank you so much.